All right, hello everyone. So today we're going to be looking at problem number 2 here. So we're given the graph of f of x equals absolute value of x, then g of x, and we're going to describe the transformations that are being made here to f of x to get to g of x. So the key here is to basically try to rewrite these problems in the form of a times f of x minus h plus k. So let me start by taking what I have inside the absolute value and rewrite it as minus 2x plus 5. Next thing I'm going to do is I'm going to factor the negative 2 out of there. So it's x minus 5 halves. So what we want is we want the coefficient of x to be 1 in so many words here. All right, next step is this. I'm going to rewrite this inside where the absolute value is at as the absolute value of minus 2 times the absolute value of x minus 5 halves. We are allowed to do that. There's a property that says if you take the absolute value of a product of two things, it's equal to the product of the absolute values. And the absolute value of minus 2 is just 2 in itself. And lo and behold, you can go ahead and cancel out the 1/2 and the 2 on the denominator and the 2 there. So you get negative x minus 5 halves minus 3. And this is in the form that we want of a f of x minus h plus k. So our goal is always to make our function, make it look like what we have here in red, as again a times f of x minus h plus k. And then from here we can identify each of our a, h, and k here. So in our case a is minus 1, so this stands for a reflection across the x-axis. We have h is 5 halves, and that is a horizontal shift to the right. Okay. So if your h is positive, it's to the right. If it's negative, h is negative, then it's to the left. And then last but not least, you have your k, which is minus 3. So this is a vertical shift down by 3 units. Okay. Let's rewrite this 3 here. And so these are the transformations that are being done to the absolute value function to get to the graph that we need now. Let's go to the actual graphing. So this is the graph of of absolute value of x with 2 points on here. And Professor Dell'Olmo might require you to do 3 points or more, but I'll just keep it at 2 today. And what I'm going to do is this. I'm going to go ahead and draw out each of the transformations that we have in different colors. So I'm going to start with my reflection first. And I typically like to start with any reflections. So the reflections here, I'm going to work with the absolute value of minus x would be minus absolute value of x. That would be my first graph. That would be the reflection across the x-axis. So what does that do? So reflection basically changes the sign of the y values. So the point 0, 0 stays as is. The point 1, 1 becomes 1, negative 1. And ultimately what happens with our graph here is that it becomes like an upside down V in a sense. It flips over the x-axis essentially. So reflections basically are like flips over the x-axis. All right, that's the first one, minus absolute value of x. Let me make that here. Next thing I'd like to do is I would do any vertical stretches or shrinks if I had a value of a here on the outside, but I don't have it. So we're not going to worry about that today. Next thing is I'm going to go ahead and do my horizontal shifts, which is x minus 5 halves, absolute value of negative absolute value of x minus 5 halves, excuse me. So when you're doing these intermediate graphs, you work with the previous graph and then you apply the next shift to it. So x minus 5 halves, that shifts everything over 5 halves units to the right. So going back to my graph up here, starting with the red one, I'm going to take that 0.00 and move it over 5 halves units to the right. So that affects the x values. So 0, 0 becomes 5 halves 0. I just added 5 halves to the x value. The y value stays the same. 1 negative 1 would become 7 halves negative 1. And your graph basically looks something like what I'm drawing out here. So there we go. All right, and then last but not least, we have our final shift, which is the -3. And that is a vertical shift down by 3 units. And that is when we subtract the 3 from the absolute value of, negative absolute value of x minus 5 halves. So when you're shifting down or up, what that does is that it affects the y values. You add or subtract whatever that k value is to the y's. So for example, 5 halves 0, because I'm shifting down by 3, becomes 5 halves negative 3. And 7 halves negative 1 goes down by 3, and it would look like 7 halves minus 4. Okay, and so your graph essentially just went down 3 units here, as such. Okay, and there we go. So again, just to reiterate what we did, we rewrote the function in the form a times f of x minus h plus k. So your goal is to isolate the x, have it a coefficient of 1, excuse me, and then pull out any numbers on the outside or whatnot, and then work from there, and then identify your transformations like we did. And then we went on to the graphing, and we did these one at a time, starting from the parent graph, the absolute value of x, and we reflected it first, that was in red, then we moved it over to the right 5 halves units, and then down 3, and that would be your final answer. So as I said, press or del on might require you to do more points, but as I said, just decided to do 2 here. But the more the merrier, though, basically, with these. All right, well, I hope this helps. Thank you for your time.